Okay, this is a video on how you can graph rational functions quickly without doing a full key features analysis, and how you can get key features quickly just by looking at the equation. So let's dive right in. If we have a rational function that is a degree 0 over a degree 1, so that means we just have a value like 2 or 3 or 4 or 1 over the equation of a line. So this is degree 0 over degree 1. What that should tell you right away is the degree of the denominator is larger, which means your horizontal asymptote is going to be 0. And that's true of all rational or reciprocal functions, and it's true of all functions in which the degree on the bottom is higher than the degree on the top. So we're going to start by showing that we have a horizontal asymptote at y equals 0. Vertical asymptotes come from the denominator. So if we set the denominator equal to 0, cx plus d equals 0, and we start to rearrange, we would get negative d equals cx, and x equals negative d over c. So the vertical asymptote will always follow that pattern, negative d over c. So in this case, negative 5, if we switch the sign, becomes positive 5, divide by 2. Our vertical asymptote in this case is 2 over 5. So that's about 2.5, not about, it's exactly 2.5. So for our sketch, we would have a vertical asymptote at x equals 2.5. X-intercepts come from the numerator. So you take your numerator and set it equal to 0. In this case, that would be taking b and setting it equal to 0 and solve. Or in this case, it would be taking 2 and setting it equal to 0 and solve. 2 can't equal 0. So we have no x-intercepts when we don't have a x term in the numerator. No x-intercepts. Y-intercepts? Y-intercepts come from taking the whole function and replacing x with 0. If we do that, we would have b over c times 0 plus d, which would give us b over d. So our x-intercept is just b over d. And b over d in this case is negative 2 over 5, b over d. Yeah, so that'd be 2 over negative 5, which is negative 0.4. So that means we have a point right here. And then we just have to bend with our asymptote. Since we have a point in this quadrant of the graph, we're not going to have a point in this quadrant. So we're going to bend and touch our asymptote, and then bend and touch our asymptote. Not touch our asymptote, approach our asymptote. Since we have a graph in this section, means we're going to have our second section up here. So we're going to bend like this around our asymptote. And this is enough detail for you to have a correct graph. For rationals of this form, degree 0 over degree 1, your rational is always going to appear in opposite corners of the graph. So it'll either be bottom left, top right, or top left, bottom right. And that'll always hold true when it's degree 0 over degree 1. If you wanted to check, you could plug in numbers to the left and to the right of 2.5 into your equation and look for the behavior around the vertical asymptote. You could plug in large values of x and look for behaviors around the horizontal asymptote, and large negative values of x and look for the behavior over here. But once you know where one point is, that's the section of the graph that it's going to stay in. So it's going to approach and go down, it's going to approach and go left, and we're not going to cross any asymptotes when we're degree 0 over degree 1. So we know we'll have a section here and a section in the opposite corner over there. And that's a quick way to graph of that form. Quick way to graph of the form that we did the full key features analysis on, which is the first part of the video, is to do similar to what we did above, but this graph looks a little bit more complicated because we actually have a degree 1 over degree 1. When the degrees of the numerator and denominator are equal, the horizontal asymptote is the ratio of the numbers in front of x. So that would mean it would be a over c. In this case, a is 4, c is 2. 4 divided by 2 is 2. Your horizontal asymptote is going to be y equals 2. Vertical asymptote comes from the denominator. You take your denominator, set it equal to 0, and solve. So in this case, it's going to be 1 over 2. But using letters, it's the same as above, negative d over c. Just taking cx plus d, setting it equal to 0, and isolating for x. You get negative d over c. So negative d would be negative negative 1, which is 1, divided by c, which is 2, is 1 over 2. So we have a vertical asymptote right here at x equals 0.5, or 1/2. X-intercepts come from the numerator. So take your numerator, set it equal to 0, and solve. That would be negative b over a if we're using the letters. If we're using these numbers, we would move the 1 over. Sorry, I'm going to show you the math here. Move the 1 over and divide both sides by 4. So we get x of 1/4, and that's your x-intercept. So your x-intercept is 1/4, and that would be right here. Y-intercept comes from replacing the x's with zeros, so that would eliminate your ax term and your cx term, and would leave you with just b over d. B is negative 1, d is negative 1, negative 1 divided by negative 1 is 1. There's our y-intercept at 1. Same rule applies for degree 1 over degree 1. If we have a part in this section of the graph, we're going to bend and approach our asymptotes in this section of the graph. There we go. Since we're in the bottom left, we're going to have a section in the top right, so we bend and approach in both directions. If you want to confirm this, you can do it by looking for behaviors around x equals 1/2 and y equals 2 by plugging first for the horizontal asymptote large values of x to test the behavior here, large negative values of x to test the behavior here. If you want to test around your half, you plug in a number just less than 0.5, like 0.49, and show that you're getting a negative answer. And greater than 0.5, you plug in like 0.51 and show that you're getting a positive answer to show that behavior. That's a degree 1 over degree 1. The last form that you might see is what if you have a degree 1 over degree 1 where you have a common factor. So that means we have an exception to example 2 because we have a common factor. When you have a common factor, it will divide away, and that restriction becomes a whole. If you divide 4 times x minus 2 by x minus 2, you're just left with 4. But there's a restriction that x cannot equal 2, and that restriction becomes a whole. So we have a whole at 2. Will we have a vertical asymptote if we have a whole? No. Will we have a horizontal asymptote if we have a whole? Potentially, but not when it's a degree 1 over degree 1 and we divide it away. There's no horizontal asymptote when we have a degree 0 polynomial function. So no. Will we have a y-intercept? Sorry, an x-intercept? No. Will we have a y-intercept? Yes. It's whatever number you're left with. It's your constant term. So in this case, we're left with 5, which means we have a horizontal, 4, which means we have a horizontal line through 4. And our graph looks like this, except it doesn't go through the hole. And there's our function. So, what is the summary? Degree 0 over degree 1. We can graph it by using key features. Very quickly summarized here. It's a nice sketch. If we have a degree 1 over degree 1, without doing a full key features analysis, we can sketch it quickly by looking for vertical, horizontal, x-intercept, y-intercepts, and then assuming behaviors by which section of the graph we end up with our x and y-intercepts in, and then using the opposite section for the other portion of our graph. The only exception to this degree 1 over degree 1 is when you have a common factor and it divides away, and it's done quite quickly by dividing the common factor away, using what you're left with to graph your horizontal line, and using the restriction as your whole. No vertical asymptotes, no horizontal asymptotes, no x-intercepts, just the y-intercept wherever the horizontal line crosses the y-axis. So that's quickly sketching rationals. So what strategy should you use if you have a question in your homework, for example? Well, if you're just asked to sketch, you can use this strategy to come up with your sketch. If you're asked for a full key features analysis and graph or sketch, you need to do the first part of the video lesson, where you do a full key features analysis in order to graph. And that's it for part 2 or video 2 of lesson 5.3. Thanks for watching.